Hello, my favorite pre-cal class. It is Miss Letchworth again, and if you're lucky, I will sing to you again. I don't know. Depends on your definition of luck. But anyway, okay, so Unit 5B, Lesson 1. We are graphing sine and cosine. And, you know, I'm at home doing this over the long Veterans Day weekend. I hope y'all had a good weekend. My dog, she's sitting behind me. She's deaf. Bless her little heart. And she is snoring, just let me tell you, so you might hear her. I don't know. We'll see. But anyhow. All right, so let's talk about graphing sine and cosine. Enough about that. Standard form of the equation of a sine function or a sine graph is y equals a times sine of b times the quantity of x minus c plus d, or sometimes that d right there might be moved around in the front and they try to trick you a little bit, make you think that d is actually a because it's in front of sine and it's not. So anyway, forgot to tell you something. There is a note-taking guide for this. Note-taking guide. Okay, so you can follow along with this, all right? And not have to write all this stuff down. So I do have all this stuff already photocopied for you in a lot prettier manner than this, and not abbreviated as much, so you can just follow along like I said. And unless you get ambitious and you do this ahead of time. So anyway, alright, so sine function. It's a wave. Sine kind of looks like this. If you ever played with it on your calculator, you might see that it kind of looks like that when you put it in there. Or in Math 3, you might have graphed it on the calculator. When you do graph on the calculator, make sure your mode is in radians, okay, because it makes a nicer graph than degrees. Amplitude, AMP. I abbreviate amplitude as AMP. That is how high up is this graph going to go, minus how far down is it going to go, divided by 2, also known as max minus min, divided by 2. That is one way to find your amplitude, your maximum point, minus your minimum point, divided by 2. But a quick way to find it is simply take the absolute value of whatever A is, and A is going to be a number that's in front of sine, okay? Period. Okay, period is 2 pi divided by the absolute value of b, and I just abbreviate that as p for the purpose of what I'm going to do in the next part down here. Okay, but period. How far does this graph go before it starts repeating itself? So here it goes again. Oh, yep, okay. So these trig functions, like I said, they are periodic. And so you are going to see how far they're going to go before, what is this message coming up on my screen? Hold on. Okay, got rid of that. Okay, so anyway, now P, why do I abbreviate that? It's really for the purpose of showing you how to find what we refer to as critical points. This is spelled out on your note-taking guide, but I abbreviated it as CP. Critical points are your maxes and your mins, as well as your zeros, okay? Those are the most critical points of this graph, and this is what we use to find them. First critical point is always 0. These are the values that you're going to let x equal. So these values right here are found on your x-axis, okay? And those values, of course, like I said, the first one will be 0. The second one will be whatever the period is divided by 4, okay? And then whatever you get for the period, you're going to multiply that number by 2. Then you're going to multiply, I'm sorry, not the period, whatever you get for the period divided by 4. Let me back up. Whatever you get for the period divided by 4, you're going to multiply that by 2, and then you're going to multiply it times 3, and then you're going to multiply it times 4, and that's going to give you all of your zeros, your minimums, your maximums that are in one period, okay? We will always graph 2 periods unless told otherwise, and I will demonstrate that for you because I'm so awesome. Okay. So, the shifts. Okay? The shifts depend on C and D. Notice where C is in this standard form. C is inside parentheses, okay? And it says here it's subtracted from X. There could be a minus or a plus there. That's why we always do the opposite of what C is. So if you see a positive, a plus sign right here, you're actually going to move to the left, just like all your other transformations you've learned in this class. If you see a negative there, you're going to move to the right. All right? And then D is your vertical shift. It will always be outside parentheses. That's the easiest way you can tell the difference between C and D. C always, always, without exception, will be inside parentheses. Okay? D will not. Okay? Let me see. Oh, the y-intercept for your parent function is going to always be the origin. This will change if this may change if there is a horizontal shift. And then you have flips, also known as reflections, and we're going to be flipping across the x-axis. And the way you can tell if your function is going to flip versus what the parent function looks like is if A is negative, it will flip. If B is negative, it will flip. If they're both negative, then it flip-flops, meaning, well, it was here, it flipped to there, then it flipped back up here. So it flip-flop. Get it? Flip-flop? Yeah. Okay, so anyway, so those are the important things that you need to remember about sine. Now, let's see what sine looks like. Let's graph the parent function. Oh, yes, you will be doing this without a calculator. I'm so glad you asked because I know you had that question in your head. Yes, you did. Okay, so y equals sine x. That's your parent function right there. And you're probably thinking, well, where's the A, the B, the C, the D? I am so glad you asked that question because it is right there. We have an understood A, which is a 1. That is what's in front of sine. We have an understood B, which is 1. That is what is in front of x. That looks like absolute value. Let me write that differently because I don't want y'all thinking that's absolute value because it is not. Let me just rewrite it. So 1 sine of 1, ooh, it looks like a 4. Sometimes this pen gets a mind of its own. Of 1x, okay, minus c. Oh, we don't have a c, so it's 0. Plus d. We don't have a d, so that's 0. So your a and your b, they're understood 1s. Like I said, they would be right here. And your c and your d are understood 0s. So that's like subtracting a 0. Subtracting a 0. Adding a 0 right there. Okay? That's messy. I'm going to take that off again. I don't like it. I don't like messy. Okay, so let's look at our formulas and let's fill out all this stuff because I will always ask you to talk about these 5 things on a quiz or a test. Okay? Absolute value of A is what the amplitude is. A is 1. The absolute value of 1 is 1. Period. 2 pi divided by the absolute value of B. So 2 pi divided by the absolute value of 1. Well, that's just 2 pi. Okay? Critical points. First one's always 0. Next one, you get by saying 2 pi divided by 4. Yeah, you may have to come over to the side of your paper and do that. Okay? But you're going to divide that by 4. That's going to give us pi over 2. Okay? The next one, we take this, we take pi over 2, and we multiply it by 2. Well, that's going to give us pi, right? And then the next critical point, we go back to pi over 2, and we multiply it by 3. And that will be 3 pi over 2. And then the last one, we go back to p over 4, pi over 2. We multiply it by 4. And this is the cool thing. If you did it right, that last critical number will always be the same as the period. Yes, it will. Okay? Also, if the period is 2 pi for any of your trig functions, the critical points will always be the quadrant angles. Do you recognize these as your quadrant angles? There's your 90, your 180, your 270, your 360. Okay? Shifts, well, C and D are both 0, so there are none. Okay? So what you have to remember is a blank answer is a wrong answer. You will put something there. Okay? If you leave it blank, I will mark it wrong. I'll assume that you just didn't know. Okay? All right, flips. Well, check out A and B. A is positive, B is positive. There are no flips going on. So again, a blank answer is a wrong answer. So we found all that information out. And with some of your homework problems, that's all it's going to ask you to do. You won't graph all the homework problems that I give you. All right? But let me erase this because I'm about to graph this, and I'm going to graph it over here. And these graphs are pretty easy to do just on your notebook paper. Okay? And that's usually how I organize mine on my notebook paper. I list everything like this down the left-hand side and then right beside it on the right-hand side. I just draw my graph. Now, if you want graph paper, then by all means get you some graph paper. It's okay. All right? It would probably be prettier, and you could see your scale a little bit. But like I said earlier, when you find your critical points, these are your x values. So they're going to go on your x-axis. Well, there's 0. It's already there. I'm going to label this one as pi over 2. And this one is pi. And this one is 3 pi over 2. And this one is 2 pi. And I also told you you would be graphing 2 periods. Well, remember 0 to 2 pi is 1 period. So what we're going to do is we're just going to come right over here. And we're going to graph the other period over here, okay? Now, sine is an infinite function. It keeps on going in that little wave manner forever, okay? So you could, by all means, keep on going in the positive direction or whatever. But I'm going to want you to always have some positive critical numbers and some negative critical numbers so you can see what's going on around the origin right here. Okay? All right, and with the y-axis, because eventually we're going to start talking about some symmetry with these trig functions. Okay? So, next thing you graph is this, because we got to have a y-coordinate, right? Well, we'll always graph our amplitude on our y-axis, and our amplitude is 1. So I'm going to graph the amplitude, and I'm also going to graph the opposite of the amplitude. Okay? And so this sets up our x and y axis for us. Now, if you go back to that very first page, I told you that when x is 0, y is 0, because that is your y-intercept of a sine function. Okay? And then you're just going to follow this pattern. Okay? Sine always, the parent function of sine always starts at the origin and it goes to the next critical point. It goes to the maximum of 1. And then it comes back down to the axis. And then it has a minimum at -1 on the next critical point. And then it comes back to the axis. So we have axis up, axis, down, axis. So you always hit that x-axis in between each minimum and maximum point, okay? And then we're going to connect this with a very smooth curve. And then I'm going to show you why it does this. How I know this? Well, look at your x input right here. If I let x be 0 in this function, y equals sine of 0. Wouldn't my y be 0 because the sine of 0 is also 0? Okay? If I let x equal pi over 2, put that in this function, the sine of pi over 2 is equal to 1. If I let x equal pi, the sine of pi is 0. See where those y values are coming from? If I put x in the place of, put 3 pi over 2 in the place of x right here, what is the sine of 3 pi over 2? Oh my goodness, look, it is -1. Yeah, see, get it? Okay, now you don't have to do that for these. You don't have to say, oh my God, what is the sine of negative pi over 2 and put it over here and try to think backwards and all that stuff. No, just follow your pattern here. Remember I told you that everything about trig is patterns and that the sine function is periodic. Follow this around, okay? Start right here. You're at the axis, down, axis, up, axis. Where are you going to go? Down on this one. Very good. Where are you going to go? Axis. Yes. Where are you going to go now? Up. Yes. Very good. Where are you going to go down? Yes. Axis. You see? You just follow that little pattern right on around. And then connect it with the smoothest possible curve that you can. Okay? And that is 2 periods right there. Okay? Now, we are going, that is what your parent function looks like. Okay, I don't mind that if you want to graph this on your calculator and look at, I don't know why I keep getting that popping up. But if you want to look at this on your calculator, then that's fine. But please remember that when you graph this on your calculator, you want your, ooh, there we go. That's an ugly E. You want your mode to be in degrees. Okay, it just will make your life so much simpler. It is, okay? This is just giving me a little bit of a fit here, okay? So make sure that your mode is in degrees, okay? All right, so your handout says for you to graph the opposite of sine x on the same coordinate plane. Since we're going to do that, I am going to identify this as y equals sine x. Okay? If you think about it, if you go through all these, and on the handout I didn't give you room to list all of these things, but if you go through all of this with y equals negative sine, you're going to see that all of these are going to be the same, because if I identify A, B, C, and D here, remember I can write this as negative 1 sine of 1x minus 0 plus 0. So A is a negative 1, but if I take the absolute value, my amplitude will still be 1. B here is still 1, just like it was up here. So the period for negative sine x is still going to be 2 pi. And then, of course, if I find, all my critical numbers, I'm still going to get the same thing, and C and D are 0, so no shifts, no flips. Right? I'm sorry, I do have a flip. Oop! Flips! This one's going to flip. Sorry. Okay? But I have no shifts. But flips I do have because A is a negative 1. And your rule for flip says that if A is negative, you have a flip, okay? But looking at all this other stuff, it's going to be the same, okay? So really, all we're doing with negative sine x is we're just going to flip this, okay? Well, any point that is already on the x-axis is going to stay on the x-axis because we're flipping across the x. And if the point is on the x, it can't flip over it. It's going to stay on it. But this point right here is sitting at positive 1. We're going to flip it down to negative 1. And this point right here sitting at negative 1, we're going to flip it up to positive 1. And this one sitting at positive 1, we're going to flip it down to negative 1. And this one sitting at negative 1, we're going to flip it up to positive 1. Okay? And if you don't have colored pencils, you could always like dot your graph or something if you wanted to. But this is what it looks like when sine flips. Okay? So this function right here is y equals negative sine x. Okay? So everything is the same. Now, the reason I showed you that is because I graph all of my sine functions based off of this idea right here of knowing my parent function, and that's the big deal, okay? You need to know what this parent function looks like, okay? You also need to know what it looks like if it were to flip, because that's where I always start when I graph sine functions. So let's see what a function looks like when we've got some flips as well as some shifts in there, okay? So let's go over to number 4 and let's analyze all of this stuff. Let's see what we've got here. First of all, the 2 right here is in front of sine. So I know that this is my A. Negative 4 is in front of x. I know that that is my B. I don't have anything added or subtracted inside of parentheses, so I don't have a C. There is no C, meaning there will be no horizontal shift. But this plus 1 is not inside parentheses. That tells me that that is D. Remember in the beginning I told you the way you could tell the difference between C and D is that C is always without exception inside the parentheses. D is not. Okay? So let's analyze what we've got here. My amplitude is the absolute value of A. A is 2, so the absolute value of 2 is 2. Now, I know you don't have these formulas memorized like I do yet. That's why you've got a handout. Look at them as I say them, okay? The period is 2 pi divided by the absolute value of B. Amplitude and period are always positive numbers. That's why we take the absolute value, okay? So when I simplify this, then I get 2 pi divided by 4, and that simplifies to be pi over 2. Okay? That's very small. I mean, you're talking about all of those angles are just going to be in the first quadrant. That's all. They're only going to go up to pi over 2 before they start repeating themselves. That function is, okay? All right? So that is pi, and I meant first quadrant on the unit circle. Okay? So the period here is going to be pi over 2. All right, your critical points, remember the first one's always 0. All right, you're going to take this one and divide by 4. So remember that dividing by 4 is the same thing as multiplying by the reciprocal of 4. So that first one's going to give us pi over 8. All right, now remember, when you've got the first that first one right there, okay, then your next one, you're going to multiply by that one. Multiply that one by 2, I'm sorry. And then you're going to multiply it by 3. And then you're going to multiply it by 4. And that's how you're going to get your next one. So when I multiply 2 times pi over 8, I get pi over 4. And then this one right here is going to give me 3 pi over 8. And this one right here is going to give me pi over 2, which is right because remember that last critical point is supposed to be the same as the period. Okay? All right? Shifts. Okay? We already said we have no C, so no horizontal shifts, but we do have a D, which is a plus 1. That means that this graph is going to shift up 1. Okay? And do we have any flips? Check out A. Is it negative? No. Is B negative? Oh, yes it is. So yes, we do have a flip, don't we? Okay? All right. So I'm going to erase all my scrap work over here. And I'm going to set this up to graph my function. Okay? And the setup is really the same, and it kind of gets boring sometimes when you're trying to set everything up. Okay? When we're setting up our graph, that's kind of when we like to chit-chat a little bit, you know? Yeah. Okay. So this is pi over 8. I spent the day yesterday with my mother. It was fun. She's 80 years old. Sweet as can be. She had a little procedure done yesterday. That was no biggie. Oh, excuse me. Let me interrupt my story about my mother. So I put all of my positive critical points over here. Now I'm just going to put the negative ones over here. But she did fine. my dog and I, we spent the night with her last night, took care of her. It's important to take care of your parents when they're older because, you know, they're taking care. What is that? Because they're taking care of you now. Okay. There we go. All right. So amplitude is 2. So remember, you always put your amplitude on your x-axis. So that's going to go up to 2. And you put its opposite as well. Okay. Now, something else I like to take care of while I'm putting stuff on the x and y axis is I like to take care of room enough for shifts. I know that this graph is going to go as high up as 2 because the sine function always goes as high as its amplitude and as low as the opposite. Okay. But if I'm going to shift up 1, then I need to accommodate that and put another unit up here so that when I shift my graph, I'll have room for it, okay? Now, what I like to do when I have a shift is instead of putting points on my graph like I did over here, you know how I put my little pink points, purple points, whatever color you want to call them, on my graph and then I connected, what I like to do is I put x's on my graph where the parent function is going to be. And then I take my x's and I shift them. So shifting is the last thing that I do. This is just what I found works for me. Now you may have a better way. You may have even done this before. I don't know. But like I said, this works for me. Okay? So let's check this out here. I know I start at the origin, okay, and because I have a flip, instead of going up to the amplitude like I did a while ago, I'm going to go down to its opposite. So I'm going to go ahead and flip the graph with my x's, okay. Remember, sine normally, don't write what I'm about to write, normally sine starts here, goes up to the amplitude, axis, down, axis, okay. But because I have a flip, then I don't need to start up, I need to start down. You'll get used to this. Okay, so I'm going to start at my origin, and instead of going up to 2, I'm going to go down because there's a flip. So down, axis, up to my amplitude, axis. Okay? Don't connect these because this is not your graph. I have not taken care of this nice little shift right here. Okay? Get the second period over here. Follow this pattern around. Axis up, axis down, axis up, axis down, axis. Okay? Now what I'm going to do is take care of the shift. So these are the points on the parent function for this particular function right here. And what I'm going to do now is take everything up. Okay, so the point sitting right here at y equals 0, I'm going to move it right here to where y is 1, taking it up 1 unit. Where this one's sitting at -2, I'm going to take it up to a -1. This is sitting at 0, I'm going to take it up to a +1. This one is sitting at 2, I'm going to take it up to a +3. This one's sitting at 0, take it up to 1. This one's sitting at -2, take it up to -1. This one's sitting at 0, take it up to 1. This one's sitting at 2, take it up to 3. This one's sitting at 0, take it up to 1. Okay? And then I'm going to connect these points because this is the graph that I want right here. I don't know what in the world is going on with these streaks popping up on my whiteboard here. And this is your graph right here. And it's all done by transformations. Okay? Alright, plot twist to the next one. Here we go. Okay? y equals 1/2 sine of 4x minus pi minus 2. Okay? I have a little blurb typed on your handout, your note-taking guide. Please read it. Okay? It says that if b is not equal to 1 and c is not equal to 0, you have to factor out b first. Okay? And that is true right here. All right? So I'm going to factor out that 4, because 4 is what's in front of x. That's my b. So if b is not 1, c is not 0, you need to factor out b. And when you do, c changes, okay? Because when you factor, you have to divide both of these by 4, don't you? So when I divide this by 4, I'm left with x inside parentheses. And when I divide this by 4, I'm left with pi over 4. Okay? So factoring out b means you're dividing both of these terms right here by whatever b is. To get it in that standard form, because if you compare this to your standard form, b was outside parentheses, and then your x minus c was inside. So what that means is that 4, that's still b, but c is now pi over 4. It's not pi, so don't fall into that trap. Be very, very careful. Okay? This number is being subtracted on the outside, so that's d. And of course, this is in front of sine, is being multiplied by sine, so that is a. Okay? Alright, so we'll practice that in class. Make sure you ask about that in class if that did not make sense, what I just did right there. Okay? It's important that stuff makes sense. Okay? Alright, so absolute value of a, absolute value of 1/2 is 1/2, period, okay, 2 pi divided by 4, that's pi over 2. Hey, didn't we just do that one? We did. We just had a period of pi over 2, didn't we? Hey, don't reinvent the wheel. You already found those critical numbers, didn't you? Write them down. Okay, so 0, pi over 8. I don't know what that is. Why those streaks pop up like that. Okay, and then 2 times that was pi over 4. 3 times pi over 8 was 3 pi over 8. And then 4 times pi over 8 brought us back to pi over 2. Shifts. Oh, we have 2 different shifts going on here. We have a minus pi over 4. That means that this will shift to the right pi over 4 units. And then we have a minus 2 on the outside parentheses. That means it will also shift down 2 units. And flips, let me see, both A and B are positive, so we have no flips this time. Okay? Alright, so let's see what this is going to look like on our graph. Now remember, when I draw my parent function the first time, I'm going to take care of everything except shifts. I do shifts last. Okay? My amplitude is 1/2, but I have to shift down 2, so I probably need some more room at the bottom here. Okay? So let me raise that up a little bit. And let's see what happens here. Okay, so we're going to put our critical points on the graph. Pi over 8, pi over 4, 3 pi over 8, pi over 2. Put their opposites over here. Negative pi over 8, negative pi over 4, negative 3 pi over 8, negative pi over 2. Okay? Can you hear my little Prissy snoring? My dog's name is Prissy. She's a cutie. Alright, so amplitude is 1/2. So, let me see. That is 1, that is 2. It's -1, -2, -3. I'm giving myself some more room down at the bottom because of the shift that's going to take place going down. Okay. Alright, so let's see what we've got here. Let's put our x's up here for the parent graph. Remember, your parent function always starts at the origin and for sine, and if you have no flips, you will go up to the amplitude. The amplitude is only 1/2, so I'm going to go halfway on the first critical point. Alright, on the next one, you're on the axis. On the next one, you're down 1/2 unit. And then on the next one, you're on the axis, okay? So that's what it looks like before I take care of any shifts. That's what your parent function looks like for this function right here, okay? So I'm going to follow this right on around. Okay, I was axis down, axis up, axis down, axis up, just 1/2 unit here now, and then axis, okay? Now what I'm about to do is my shifts. My shifts, I have to go right pi/4 and then down 2, okay? When I move a graph to the right, I always start at the far left because all of these points right here are going to go this direction, okay? And this point right here is going to go to the right pi/4 units and then down 2. Well, look at your graph and measure the length of pi/4, okay? And always measure it from the origin. The length of pi/4 is 2 of these little units right here, okay? 2 of these little tick marks. That's the length of pi/4. So when I move my x's, every single one of these x's are going to go over 1, 2 of those units because that is the length of pi/4. So if I start here, I'm going to move this pi/4, so that's 1, 2 units. That's the length of pi/4, and then down 2. Okay? And I'm on the axis, so that's going to go all the way down to -2. Alright, so this point right here, that point, it got moved. You don't have to draw what I'm drawing right here, but it got moved right there. I'm going to let that sink in for a second before I move on, okay? So this point, okay, remember the length of pi/4 is 2 of these units right here. So that point got moved 1, 2 units to the right, because that's the length of pi/4 units, and then down 1, 2. Okay? So because the length on your x-axis, 2 of these units on your x-axis equals your shift of pi/4, it's kind of like you can just count 2 units, like you're going 2 units over and 2 down, but you're not going 2 units over, you're really going pi/4 units over. Okay? Alright? Let's do the same thing with this one right here. Pi/4 to the right. Now remember, you're halfway here and then 2 down. So if I go 2 down, I'm sitting at 1/2. I'm going to go to -1/2 and then -1.5. Yeah, graph paper might have been easier. So that point got moved there. And then this one, 1, 2, down 2. You may start to pick up on a pattern right here. Okay? And now this one, to the right 2, which is really pi/4, but I'm sitting at -1/2. So skip between units when you count. 1, 2. Okay? Alright. Let's see. So, did I move this one? Oh yeah, that was the one I just moved. Okay, we're going to move this one to the right 2, down 2. Right 2, and I'm on the half, down 2. Do you see the little pattern you got going on right here? Okay, so you could start saying, oh, okay, this bottom row of points, we're at -2. And my top row of points, we're at -1/2. My bottom row of points, we're at -2.5. Okay, and I've got to complete this because when that one moves to the right too, I need some more room, don't I? I probably should not have started sketching that curve before I extended this graph. Sometimes you have to extend your graph to the right to take care of these shifts, and that means you've got to keep counting. Okay, so let me help you count here. Remember, this was 1 pi over 8. This was actually 2 pi over 8 that we simplified to be pi over 4. 3 pi over 8. This is 4 pi over 8 that we simplified to be to be pi over 2. So my next one, my dog's snoring, is 5 pi over 8. Okay. My next one, if you had to keep going, would be 6 pi over 8. But then that simplifies to be 3 pi over 4, right? Are y'all with me here? So if you have to keep extending, then that's what you want to count by. You're counting by that very first critical point after 0, the p over 4. That's what you're counting by. Okay? So let me see. Where did I stop? I stopped here. Now I moved that one to this one needed to be moved. I didn't move this one yet. Okay, so this one 2, and then it comes down. I'm sorry, this one is 2, and it's at the half, so it comes down to here. And then the next one's going to be right there because it's going to go 2 and then down. All right. So that's what your graph looks like. It's a little crazy, but it's all good. Okay. All right. Now, let's talk about cosine. Hopefully that'll go a little bit faster. Okay? Cosine. All right? Cosine is the same as sine except 2 things. The y-intercept is at 0, A. Remember, good old A? That's your amplitude. Okay? And the flips are different. If A is negative, it flips. If B is negative, there are no flips. If A and B are negative, then it flips. Okay? So cosine's a little bit different. All right? So let's graph that base function there. Remember, this can be written as 1 cosine of 1x minus 0 plus 0. Okay? So your amplitude is 1. Period is 2 pi divided by b, which is just 2 pi. And remember, when the critical points for a function whose period is 2 pi would be 0 and then all the quadrant angles. And actually, this looks a whole lot like sine. I told you it was just like it except for 2 things, right? We have no shifts. And we have no flips because we don't, A and B, neither one of them are negative, okay? So it really looks, all this right here, it looks just like sine until you put it on the graph. Okay? So here's your y, here's your x. Okay? Let's put all of our numbers up here. Okay, and on the y-axis we put our amplitude. Okay, so here's when it's a little different. Okay, cosine, it always starts at 0, A. A is 1. Okay, and from there you go to your axis, down, axis, up. See, I told you it looks a whole lot like sine. And then you follow that pattern right on around. Cosine is going to go a little bit faster than sine because you're getting the hang of this now, right? Yeah, of course you are. Yes, you are. Yes, you are. Okay, so this is what cosine looks like. I suggest that when you're doing homework, graph these on the calculator and see if you got your points in the right place. The calculator will not give you points in terms of pi. You know, like for negative 3 pi over 2, you know, your x-coordinate it'll say that it's negative 4.71 instead. Okay, but you know, just punch it in your just punch in 3 pi over 2 on your calculator and see if that's the same thing as what it's telling you in decimal form. Okay, so this is what cosine looks like. So this is y equals cosine x. And of course, when you flip cosine, you'll do the same thing we do for sine. Anything that's on the x-axis stays on the x-axis. Anything that's sitting up here at 1 gets flipped down to negative 1. And anything sitting at negative 1 gets flipped up to positive 1 for your base. Okay? And again, if you don't have colored pencils, but colored pencils, they really come in handy with all this graphing. That's why I put them on your supply list at the beginning of the year. Because, see, I was thinking of you. I'm always thinking of you. Yes. Because I heart you. Yes, I do. Okay. So, this is y equals negative cosine x. Okay? Alright, so, let's carry on. Okay? We've got 2 more problems to do, and I'm going to be done. Yes, I am. Okay, here we go. All right. 3 cosine x plus 1. Amplitude, absolute value of A. A is 3, amplitude is 3. Period, 2 pi divided by B. Hey, look, B is 1. Don't you love it when B is 1? 2 pi divided by 1 is 2 pi. And if the period is 2 pi, your critical points are what? Yes, your quadrant angles. Very good. I believe you are getting the hang of this. Hey, you need to have stick-to-itiveness. That means you need to stick to it. Okay? Don't give up. All right? Shift, I do believe we have a shift of what? What is this? Up 1. Very good, because it's not inside parentheses. This is D, not C. Okay? And do we have any flips? Well, we do not have any flips because A and B are both positive. Okay, so I'm going to set this up. Have I told you lately that I love you? Oh, I just did. Okay, let me see here. You know, I'm really not saying anything about what I'm doing here because I think by now you've got the idea of what you have to do here. It gets a little boring here. Amplitude is 3, but we have a shift up, so I'm going to go as far up as 4. And then I still have to put the opposite of A down here. Okay, now I have a shift. That means I'm going to start with X's. Okay, and when I put my X's up there, then I'm going to shift them. Okay, so remember, cosine, its y-intercept starts at 0, A. A is 3, so its y-intercept is right here at 0, 3. And then you'll go down to the axis, okay, and then down to the opposite of A, axis, and then up. Follow that pattern right on around. Okay, and then to take care of my shift, I'm going to take everything up 1. So this point's going to go up to 4. This goes up. Up, up, up and away. Hey, that was a song, like in the 70s. Google it. Because if you want to hear the rest of it, because the only thing I can sing for you is up, up and away. Ooh, this one stretched out big time, didn't it? Stretch! Did she say stretch? She did say stretch. Do you remember what the number in front of a function does? Do you remember what c times f of x does? Let me use k. K times f of x. K is the number that stretches or gives you a stretch or vertical stretch or shrink. Lolly, lolly, lolly. That's why this one stretched out so much. Okay? Because a is 3. Alright? Good job, y'all. Last one. Last one. Okay. Be careful. I have a disclaimer typed on your handout about this one to factor out b, because b is not 1, c is not 0. You will do that with every trig function from here on. Yes, we are going to do all 6. We sure are. I know you're excited. Okay, so let's factor out b. Y equals -2 cosine. Factoring out b means dividing it by whatever b is. Hey, b's not going to always be 4. I know it was last time we did this, but anywho. Okay, so that's going to be x minus, that is an ugly, ugly x. X minus pi over 8. Get hooked on fractions, because they happen. Okay, amplitude, absolute value of a. Period, 2 pi, I don't know why this is doing so ugly. It's like my pen is leaking. Who knew an electronic pen could leak? Okay. Alright, and that is pi over 2 again. Okay, so 0 is the first one. Alright, divide this by 4. Now multiply this by 2. Multiply this by 3. And then multiply this by 4. Oh, I said 4, and what did I do? I wrote it. Okay. Shifts. Right pi over 8. Up 1. And we do have a flip right here. Okay, a is negative, so we have a flip. By the way, keep this in mind. If 4 had been negative, we would have also had a flip. Sorry, I started to say the wrong thing. We would have had a flip, because with cosine it's a little different than sine, remember? Okay, but we do have a flip here, so yes, we do have a flip. Alright, so let's set this up. I think I'm going to have plenty of room to do this here. This is the last one, y'all. Pi over 8, pi over 4, 3 pi over 8, pi over 2, negative pi over 8, negative pi over 4. My dog, she came and she laid right down beside the laptop and is snoring. It's so funny to me. I don't know if y'all can hear her or not. She's a cutie. She's 10. She's deaf. But she is a lovely, lovely, lovely little puppy. She's still my puppy. Okay, so, alright, remember, I use X's if there's a shift. I only use X's if I have a shift. It just works for me, okay? Y'all can do what you want, okay? But this works for me. Alright? Okay, cosine is flipping. remember what that looks like. If cosine flips, instead of starting up here at 0a, okay, we're going to start at 0 negative a. So we're starting down here, okay? Alright, so we're going to go to the axis, up, axis, down. Follow that pattern right on around. Okay. Alright, so now we're going to talk about the shift. Okay. The horizontal shift is pi over 8. Do like I showed you a while ago. Figure out how far that is from the origin. From the origin to there. That's the length of pi over 8. It's just 1 unit. Okay. Sometimes you really have to be careful because, I'll make that a little dark. No, what's a good color? Is this a good color? No, none of these are good colors. They don't really show up, do they? There we go. That's pi over 8. But anyway, sometimes, like your shift might be, I don't know, pi over 16 instead. And that would be like halfway between. So sometimes you will have a shift that's only halfway between a unit or something. You have to be really careful then, okay? But this shift right here is going to be just one of these little units. All of these are pi over 8 units apart, every single one of them, okay? And then we're going to go up 1. So just like I did a while ago, I told you that if you have a shift to the right, start on the far left. If your shift was going to go to the left, start on the right, okay? So I'm going to start right here on the right, and I am going to go to the right, pi over 8, and up 1. So pi over 8 again, remember, it's just one little unit. So right, and then up 1. Okay, so this point right here just got moved to the right there. Okay, that's where it got moved to. All right, that was my attempt to draw a dotted arrow. Good job, Miss Letchworth. Okay, right pi over 8, up 1. 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 But I need to extend here, don't I? Remember what you do if you have to extend. Okay, remember this was 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8. 6 pi over 8, which simplifies to be 3 pi over 4. Okay, so now I have room to move this one. I can go to the right and then up. Okay, and this is what my graph looks like. I'm going to connect this with a smooth curve. Oh my goodness, I think it looks like I tried to tie a bow. I don't know what in the world. There we go. Well, it ain't pretty, but that's it. Okay? And that is all there is to graphing sine and cosine. Okay? Next 2 days, we're going to be doing secant and cosecant and tangent and cotangent. And you're going to have a lot of rules. Okay? Make sure you take really good notes. Okay? Take really, really good notes. You will be glad in the end that you took really good notes. And that's all I'm going to say about that. I'm not going to say why, okay? But take really, really good notes. All right? Okay. Have a happy day. Always.